Okay, so we have been doing basically to find out rotation about an arbitrary axis in 3 dimension. So we found Jx, Jy and Jz. I denote this as J1, J2 and J3. So we got 3 matrices. Basically, what was J1? J1 was, J3 was
0 minus
J3, Jz was 0 minus I 0 0 0 0 0 0 and J1 or Jx
0
0
0 0 0
0 0
minus I 0 0 minus I 0 I 0 0 I 0.
Okay, and J2 is 0
0 0
I 0 0 0
0 0 0
minus I 0 0.
0
Okay, good. So we have the rotation about x-axis, y-axis, z-axis separately. So each of them we can actually see it as suppose any axis e power I. The rotation matrix is nothing but r is equal to, for suppose it is x around x-axis. So we had a notation. What was the notation? R, okay, about the x-axis, an angle psi was what? Which was equal to e power I j x psi, right? This is what we had. So similarly we have y about the y-axis, which is equal to e power I j y psi, and about the z-axis e power I j z y.
So it could be a camera is a little out of focus or blurring something. So it keep getting blurry in between.
Are you able to see the board?
So we are able to see, but it's a little blurry. So if you can write a little bigger, that would be fine. Just a little bigger. Yes, it's clear now, sir. It's clear now. But again, blur. Yes, sir. It's clear now.
Is it clear now?
Yes, sir.
Okay, okay, fine. So Rx about the x-axis, rotation about an angle psi, R is basically this one, and similarly R for about the other two axes are these two. Okay. So you can see that this you can call J1, J2, J3. So let me now onwards call J1, J2, J3. So J1, J2, J3, these three quantities actually transforms like vector under the rotation, okay, that you can actually show. They are matrices, but they transform like vector. So we can write down the general R about the n axis, then angle psi as e power I j dot n psi. Okay. So this is nothing but e power I j1 n1 plus j2 n2 plus j3 n3 psi. Now is this e power I j1 n1 plus j2 n2 plus j3 n3, is this equal to e power I j1 n1 psi plus e power not plus multiplication I j2 n2 psi e power I j3 n3, is this equal to this one? Is this quantity equal to this quantity?
No, sir.
No. Why? Because j1, j2, j3
Don't commute.
do not commute each other. Okay, so this is not equal. So we should have a way to find out this quantity, because so this is, what is the dimension of this matrix? E power I j1 n1 plus j2 n2 plus j3 n3. Okay, what is the dimension of this matrix?
3 cross 3.
3 cross 3 cross
3.
3 cross 3. Okay, so this is a 3 cross 3 matrix. So what I can do is I can call M a matrix M, which is, I just denote it as I j dot n. Okay, so this is unit vector, so this is j. So what will be M matrix now? This one you can write down. What is M matrix? Basically take j dot n. So n is, okay, what is n1, n2, n3? Because the unit vector that components, okay, along these three axes. And we also have is a unit vector, so n1 square plus n2 square plus n3 square power 1 by 2 is equal to 1. Okay. So what is the matrix M, which is basically equal to I j dot n? So basically you have, what you have to do is you have to take j1 n1, multiply this with n1 and multiply with this I. So what you get, this first one, if I multiply with I, this will become plus and this will become minus, right? And this quantity will be plus 1 and minus 1, then I have to multiply with this, so j1 n1. So what is j1 n1? I j1 n1. So what is this quantity equal to? 0, 0, 0, 0, 0. Here n1, 0, n1, minus n1, 0. So similarly you can do other things. So what is I j2 n? Quickly you tell me. I j2 n2.
0, 0, minus n2.
0, 0, minus n2. 0, 0, 0, n2, 0, 0. Then I j3 n3 is equal to 0, 0, 0. Is it 0, 0, 0? No. So this is n3, 0, n2, n3, 0, 0, 0, 0, 0. Okay. So if you add these two, what are you going to get? That is this matrix M basically. Okay.
So in the second row, should it be minus n3?
This is minus n3. Yes. Okay. So what is this equal to then? M is, so this is there is a summation, right? This is j1 n1 plus j2 n2 plus j3 n3. So these three you have to add. So if you add those, what are you going to get? 0, 0, minus n2, then
So 0 n3 to minus n2.
n3 minus n2, then minus n3, 0, n1, okay, n2 minus n1, 0, okay. Because if I now basically this matrix, that is R rotation about to n, and angle psi is now nothing but e raised to m psi, right? E raised to m psi. So if you expand this, if it will have term m square, means identity m square, m cube, all those powers of m's will be there. So see whether we can actually get a compact form. So m is this. So if m is this, you have to find out m square, right? And m cube and so on. So see whether anything interesting comes out. So for that, can I write down this m as some epsilon ijk nk? Is this m is equal to not m, mij, whether mij is equal to epsilon ijk nk. Is it true? Just verify whether this is correct.
Yes, sir.
That is correct, right? Okay. So what is m square ij? Let us see whether we can get a very nice expression. So what is m square ij? If mij is this one, what is m square ij? So a matrix, two matrices if you multiply, and ijth component will be equal to individually what you get, a ik b kj, right? So this is the ijth component of the matrix A into B, a ik b kj, there is a summation over k. So that is basically the, so this will row and bkj is a column, okay. So you multiply it like that. So m square ij is, then how will you write down? So basically this m into m ij, so that is equal to m ik m m kj. So mik you have to substitute. So what will I substitute for mik? What will mik equal to?
Epsilon ikm nn.
Epsilon ikm, you write nm, another one epsilon k j l l l, right? Is it correct?
Yes, sir.
Yes. So what is epsilon ik mean to epsilon kjl? So there is a formula, right? You know, remember that formula. If one index is same, so k index is same in both, right? So one index is same, you can use the delta, right? So you just substitute that formula. So what is the formula? Epsilon, if I have a same index k I j epsilon k l m, which is equal to delta I l delta j m minus delta I m delta j l. Okay. So it is better you keep this k in the first place. So if I keep k in the first place without a sign, what will be this equal to? IKM is same as k KMI. Okay. So this is same as KMI. Now you can apply this formula and get the answer. Can you all spend 2 minutes on that? Whether you can get a nice answer for this. How many free indices are there in this equation?
2.
Obviously, because left hand side is 2 and all other things are dummy indices. So delta m square ij equal to delta m j delta I L n m n L minus delta m L delta I j n m n L. So can I simplify this, because this exists when j is equal to m, right? So I cannot remove j actually wherever, because summation is on m. So wherever m is there, I should replace with j, right? And remove this delta. Wherever there is an L, I should replace L with I and remove this delta. So this is equal to n j n I, right? N j n I. And this one, wherever m is there, I should replace with L. So n nl dot nl. NL NL, okay, not NL dot NL, is N dot N basically, NL NL, delta Ij. What is this quantity?
1.
That is 1. Okay, so answer is Ni Nj minus delta Ij. So similarly you can find out m cube, okay. So similarly you can find out m cube, and so m cube is very easy. So what you should do, you just multiply with the m here, okay. So basically m cube is equal to m square into m. So ijth component of m cube is equal to ijth component of this, right? So this is equal to m square ikth component, m square matrix ikth component, then m matrix j k jth component, okay. So what is m square ik component? M square ik component is ni nk minus delta ik. What is mkjth element? Mkj element is epsilon k kj, you use something else, m. So into kjm nm.
Ma'am. And then
So what is the second term? What is second term equal to? See, I am doing this explicitly because I want all class to understand these calculations. Okay, some of you it may be very easy. So what is the second term?
It will be 0 because whenever delta is 1 then epsilon will be 0.
Yeah, so whenever delta is 1, epsilon is 0, or whenever epsilon is 1, delta is 0. So you can actually put it in another way, nice way. A product of symmetric tensor with antisymmetric tensor will be always 0. Okay? A product of symmetric tensor with antisymmetric tensor will be always 0. So this is a symmetric tensor, this is an antisymmetric. Okay? So what is the answer? Epsilon kjm nink nm.
So but why epsilon would be 0 when I equals to k because epsilon doesn't have any I index.
Okay, so let us look at this. So epsilon does not have I index, fine. Okay, so now let us look at this. This I is a free index. Oh my god, one second. So I is a free index and j is a free index. So you take any I or j. Okay. So for example, you take I is equal to 1. Then the k should be 1. Right? K should be 1. If k is 1, so otherwise this is not 0. So when k is 1, jm. So jm is there. What are the values j and m can take? J and m can take? J, now j also, yeah. So m can be anything, right? M can be anything. So j should be 2, right? So because already, so let us look at that. Yeah, whatever is point is very clear because if the indices are not free, we can easily say that symmetric and antisymmetric concept. But his question is ik epsilon kjm nm. This is the quantity we are talking about. Okay. So here, suppose you are looking at the 1 element of this. Suppose you are looking at the 1 element. So if it is a 1 element, so you get delta 1 k epsilon k 1 m n m. What is this? So k can take any values. If k should be 1, this to be non-zero. If k is 1, this quantity will become 0. So 1 term is 0. So now let us look at 1 2. So if as k is 2, so this is 2. Obviously 1 2 will be 0, right? I can have this one only non-zero when I is equal to k, right? So so now 1, okay, fine. So fine. So j1, if I put, that is obviously that is equal to 0 because k should be only 1. And j is equal to 2. Suppose j is equal to 2. So what you get? J is 2. So this I can have only 1. So 1, 2, m. But m can take values. So there will be 1, 2, 3 term. So you get n3. Okay. Yeah, so he was right. Okay, so we cannot simply say that it is cancel each other. Okay, because these two together actually give you a one answer. Because how many non-zero components will be in this? How many non-zero components will be in this? There will be three non-zero components. So obviously those three will not cancel each other. So there will be three non-zero components here. What about here? The first term, how many non-zero components are there?
6.
6. So there are 6 non-zero components there. And you have to see those 6. Let me see whether we can actually get this one in a nice fashion. We can get, if you do this, we can finally get our answer. That is not the question. So, so this one. Pardon me? Epsilon ijm, delta ik and epsilon kjm as, okay, okay, so so you are saying delta ik epsilon kjm. Obviously there is a delta ik, there is a summation over k, so I can remove this delta, and so let me not worry about the minus sign. So I can remove this delta by replacing wherever there is a k, replace with the I. That is what you are saying, right? So this is I, j, m. So this is fine. Yeah, so this, yeah, this is correct, right? Epsilon ijm. I can write this as epsilon ijm, right? Yes or no? Can I write this is equal to epsilon ijm? That is the same. Yes.
Yes, sir.
Okay, so now so this one epsilon kjm nm minus ijm nm. So what is next? So you want to simplify further, and I and j should be different, so that is fine. So ij m nm, and this is kj m nm. Okay, so what is this quantity? Minus epsilon ij m nm. You don't worry about this. What is this quantity? Epsilon ij m nm. Anybody?
MIJ.
That is mij. So this is minus mij. Actually that is the answer, so that basically meaning this quantity is 0. Okay, so this quantity is not 0. Okay, because I cannot apply the symmetric and antisymmetric here, because they don't, all the indices does not sum. Okay, so there is a summation over those indices only, we can actually say that. Okay, because I and j are free indices, so that is not correct. Okay, that statement is not correct. So this one we got it as, so this is actually, this is the only answer I am supposed to get, because this should be 0. So can I see that this quantity is 0? Okay, so that is why?
Sir, because for every time, so there will be 6 terms and all the terms will cancel each other, sir. Like for example, the 2j3 term and the 3j2 term will cancel each other out. Similarly, for every, if k and m are same, then it will be 0 as it is. If k and m are different numbers, then they
Yeah, because k is summed over, m is summed over, okay, and I and j are free index. So obviously k and m should not be equal to j, right? So the free index does not play a role here, right? Because that is separate. So k and m should be different. So obviously there will be a pair 1, 2 here when j is something else, not a 1 or 2. Okay, so in that case, all those pairs will come in with the opposite sign. Right, good. So this is equal to minus mij. So now it is very clear that I can write down, so basically m cube is equal to minus m. That's what basically this is saying. So m cube is equal to minus m. Now our life is simple, right? Because there is a truncation coming. Okay, truncation in the sense that now we will be able to write our series in terms of cosine sine. So that part I am leaving to you. Okay, so this answer I will write. You derive that. That is. So what you want to do is the Rijth term of, okay, n psi is equal to delta ij cos psi plus ni nj 1 minus cos psi. This is a very useful expression when you do the rotation in 3 dimension. So there are so many problems we can do with this. Maybe I will give you an assignment or a class test. Okay, so you look at Balakrishna's book. Okay, there are so many problems based on this. So all of you just derive this. So up to this m cube is equal to minus m you got. From that, so find out Rij n psi. Okay, so this you can easily do.